name's Anna Tinbenzel. Welcome back to my channel. I am here today with JoJo, and we are on LeetCode problem number 40, combination sum 2. Now, I was trying to do this all in one day, and after 9 LeetCode problems in one day, my brain was ready to tap out. So I've given myself a couple days and 9 minutes to read through this problem that we have here. So this is, again, LeetCode problem number 40, and the solution is going to be done in Python. So let's jump into this question. So given a collection of candidate numbers, good grief, candidates, and a target number, find all the unique combinations in candidates where the candidate numbers sum to target. Each number in candidate may only be used once in the combination. Note the solution set must not contain duplicate combinations. It's going to be a rough day. I'm really sorry, guys. And so they give you these examples, and then they give you these constraints. So when I read through this the first 2 times, I had a few thoughts, but I think what I'm deciding to do overall is start with a recursive function, because I think that we'll be able to explore all of the different candidate numbers in a way that we can also reduce the runtime of. So what I'm going to do is start that recursive call with maybe a def backtrack, and then start it with a results list. And then I guess I'll kind of figure it out from there, but that's kind of my vision with this. And then we can have an append results so that it appends a copy of that current combination of the results list. So less talking, more doing, so I can show you what I'm talking about. What is it? We need start, we do need target, and then we need current combination sum. Yeah, let's do current combination. That should be good. That should cover us here. So let's then set, so that if target 0, then we're going to result append. Not going to sneak an S in there. What was I said current combination. And then we'll say this. And then we'll say return result. Okay. So I think from here, for that recursive start, is we should start breaking out a loop that iterates through the candidates, starting with, what should we start with? Index I. So for I, no, maybe I shouldn't do that. Maybe I should do that. I'm thinking of for I in range start, and then I think I want the length of the candidates, because we want their number, the length of the candidates. And then if the candidate index is greater than the target, then we break. And if the index is greater than the target and candidates index is equal to candidates index minus 1, then we should have another break. Maybe. I don't think I'm thinking of this. So I put that there. So we can do, I'm going to write that down because I actually think that might work. So if candidates I is greater than target, then we break. But if I is greater than start and candidates, did I say index? What did I say? I think candidates. I minus 1. Then we continue. Okay. Can I in range and start length of the candidates if candidates index is greater than the target. That feels good. That feels good. So then let's add the current combinations to add the valid candidate to the current combinations. And we can adjust that target by subtracting the candidate value. But we're going to have to make a recursive call to backtrack. Okay, if we make a recursive call to backtrack, then all we have to do is update the start, index, and target. And then after that recursive call, we just remove all of remove the last add candidate from the current combination to backtrack and explore the other combinations. Is that right? Or am I just talking myself into a hole? So that could be current combinations append and the candidate, so we can overwrite the candidates, but then, or the candidates index, I think. I don't know if I should put it right underneath that. I guess I probably can. So this is all I think I'll need. I went back to so let's say current combination and candidates index. I think that's right. And then, oops. And then I want to backtrack the index incremented with the target minus the candidates index. Right? Backtrack, I said index. The target minus the candidates index. And then current combination. Right? I minus index. Okay. And then we want the current combinations to populate. So I'll say current combinations pop. Okay. Now, what do I want to do now? I need to sort these candidates so we can handle some of these duplicating values so that they don't duplicate in that result. Because as it stands right now, and just looking at this test case and this test case, it would duplicate. And I don't want it to. So let's just say candidates sort. And that way we'll see those duplicates. And I guess I could maybe an empty list. So I could sort them and create an empty list to store them. And then this is where I guess I should be calling backtrack. I'm getting it in that list. So then we will start that exploration with backtrack by calling it essentially with the initial values. So then that we just need to return the result, maybe. I don't know. I think I flubbed this up a little bit logically because my brain is struggling. So my cat's playing with toys, so I'm sorry if you guys are hearing some jingly little thing. Let's run it and make sure I don't have a spelling error first off. Okay, I have a wrong answer. That's what I was worried about. What did I say? So, okay, hang on. How did it get to? Hold on. I have you guys can't see her, but it's like every time I want to record a LeetCode, she calls. She's a national treasure. If you guys don't follow her on sorry, I'm gonna reply with a text. If you guys don't follow her on YouTube, her name's Courtney Pants or Unicourt. Let me write this really quick. Okay. Okay. There you go, Courtney. She's hilarious. So I'm trying to see where I can make these changes and why my test case is coming out the way it is. So wrong here, but I'm putting in twos places. but I'm not putting in 2's here. And why is that happening? Why is that happening? Should I have initialized something to store it in before? Is it my index that's wrong? What's wrong? Current combination, def backtrack, start target, current combination. I feel like this, and maybe the recursive call isn't going to work for this, and that's totally fine, and then I just started it horribly. But I feel like I first off shouldn't have that. Let's see if that actually fixes it. No, it doesn't fix it. I was hopeful. For I in range, start the length of the candidates. Maybe this is wrong. If candidate's I is greater than the target, then we break. If index is greater than start and that also feels wrong. Please tell me my space wasn't the one ruining us. Still wrong. You never know, okay? Current combination. I'm really trying to figure out how this is not working. Candidates I. The last thing I can think of is that this would be an increment and not a decrement. Because this would all make sense for a recursive call. Nice. Well, let's see. Okay, so we ran it. It tests, but does it submit? Please. Please. Okay. Okay, I see you. Look at this. Look at this. Dang. 98. I beat 98% of users with Python in runtime and 81 with memory on this. I'm actually really surprised. I'm really impressed by that. Because that's not what I was expecting at all, considering I had my math wrong. And I feel like I said increment. Maybe I'll have to rewatch this Loom and check, because I'm pretty sure. And then when I was thinking through it in my head, I was thinking decrement, and maybe it's because I was looking up here, but that was wild. Okay, so about 26 minutes it took me to solve that, which I feel pretty good about. Yeah, I'm going to go call my friend back, but in the meantime, I'm going to throw this in the GitHub repo link that I have in the description of this video. You guys are more than welcome to fork and clone. Make it better, make it worse, have some fun, learn something new, and I will see you guys in the next video. Thank you guys so much for watching. Have a great rest of your day.